Today is the 14th of October. I'm going to talk a little bit about some progress or maybe some headway. Anyway, I want to talk mostly about the Arduino 3-axis accelerometer and point out some stuff that I didn't realize at first. As I mentioned before, this is my first time working with some of this stuff. I've done some very basic circuits in the past, but nothing where I'm using like tons of different sensors. So definitely learning a lot. And starting with a little bit just generic knowledge about the stuff, nothing too specific, and then figuring stuff out. So the main point of what I'm recording right now is the fact that a accelerometer is not going to give you the motion detection that I was looking for. So let me explain. So an accelerometer, the way it works is it looks at the values or acceleration based primarily on gravity. So what that means is two things. One, it's really only going to be able to detect the orientation when that orientation relies on gravity. So for instance, if I have the board like this, let me go ahead and start this here. Okay, right now if you look at the top box, it's doing a good job. So right here is this is the X, this is Y, this is Z values, and those two things in the middle are just little input stuff, and this is all three. Well, actually, I think right now I have it set to some craziness. So anyway, so this isn't going to do what I want to do. What I need to actually do is get a gyroscope, and then I probably need an accelerometer as a point of reference. So if you look at the shape that is looking at the X coordinate, you'll notice that when I rotate my actual Arduino board with the ADXL335 on it, it notices it can actually measure that it's turning left or right on negative values, because it's looking at that axis in respect to the pull of gravity on that axis. Same thing with if I flip the board front or back. Again, just look at the cubes at the top, not the one on the bottom. Then it also recognizes that with respect to gravity that it's turning. Now, the issue I have right now is if you look at my third shape, the Z, the one that is actually that axis is parallel to the pull of gravity, then you notice that if I'm very careful, you're not seeing any change in that axis. And that's because regardless of how I rotate along the XY plane, there's no real change in acceleration or gravitational pull on the Z axis. So this thing is going to work as a DC controller, or yeah, it'll work as a controller input method if your user is going to maintain the controller normal to the XY plane. If you do that, then the controller's fine, and you can control, tilting left, tilting right, going forward, going back. And I can show you that real quick by if I go into my code and I kill any Y coordinate or Y axis contributions. Save that. Then you should here in a second see the actual textured controller doing what it's supposed to. You see that? That looks fine. I mean, I tilt it back, it tilts back toward me. I tilt it forward, it tilts forward. Tilt left, and it goes left. But when you start combining these things, and you start getting some kind of weird stuff going on. But so I need to get a gyro so that it can sense regardless. Regardless of the pull of gravity or down. So that's what I'm going to have to order, and I'll start playing with that next week. To add in a little more, one of the things that I want to work on as far as, so my controller again is going to be kind of the concept of it is you'll have a portion that's connected to the back of your hand, lay flat there. You'll have something that will sense your fingers, and then you'll have the Arduino, because this isn't a commercial product, this is just research. The Arduino and everything will be mounted to the forearm back here, some type of strap or something there. And then in the hand and in the forearm will be two of those vibration motors that I showed you in the last couple videos. So these things right here. So those, I have those working. Those are fine. I have the push button stuff working. So what I have to do now is I have to be able to make something that is going to sense the angular rotation of my hand. And so what's going to happen with the accelerometer especially is if I have my hand like this and I rotate it this way, the accelerometer is not going to be able to track that. So when I start running it, or if I have the hand like this and I rotate this way, which is now a different axis compared to the chip on my wrist, again, because I'm rotating it around the Y, then, or normal plane Z, then you're going to run into issues with it not being able to track it. So I have to get a gyroscope to play with that, and then I'll probably use that in coordination with the accelerometer. So it has been cool to work with the accelerometer, but again, one of the primary things that's important about this is that the controller would have to be held at a certain orientation for this to work. There's another way you can kind of cheat that too, which is you can get a compass. So whereas the accelerometer is focused on gravity or acceleration in any direction, which I'll show you that in a second too. The compass will orient based on biggest magnetic pull, which is normally magnetic north, and so then you can orient your controller based on that. So that's another way you could do it, and then you can also use a gyro. So some of the most in-depth sensors for positional data actually incorporate all three, which is the accelerometer, the compass, and the gyro. But that's like $50. And so if I have to get there by the end of this class, then I will, but I'm going to go ahead and go with another $12 deal right now. And again, just to point on this accelerometer thing, if you can't see this right now, I'll try and do it as best I can. But if I just, see, I'm not actually rotating this right here. If I rotate it toward me or away from me, you see the actual thing rotating, or my objects in the game screen rotating. But watch this, if I just slide it forward, you see, I didn't actually rotate the thing. All I did was go forward, but I created acceleration along one of the planes, and so that actually created a rotational value, which is not something that we want either. Because again, you're going to be wearing on your hand, and I don't want accelerations from my hand going around to translate into rotations for the orientation of my hand, which would be incorrect. So yeah, I'm going to go to the gyro. In hindsight, it seems pretty obvious, but yeah, like I said, new to this stuff, learned a lot with this, so that's pretty cool. And then I'll finish up with, so what I want to get to as far as the hand tracking goes is I want to be able to measure how open and closed my hand is. And so one of the early projects with the Inventor's Kit is a potentiometer. Okay? And essentially what it does is increases or decreases resistance depending on when you rotate it. It's kind of like a volume knob. And so what I was thinking about doing was if I actually were to mount this to the knuckle, right, with a glove, and then have something that parallels my finger joint here, attached to the rotation on this thing, on this potentiometer, which you can't see because it's super small and the video's not high quality. Anyway, if I have the point of rotation offset from my knuckle, then as I move my finger up and down, right, then it will also move the rotation of the potentiometer, and that's something I can measure fairly easily. So the only issue with the potentiometer is it has a little bit of actual physical resistance, so you feel it on glove, but maybe as you use it more that will wear down. And two, again, this is just proof of concept, so if it's not like perfect, that's fine, because then later on we know that if you want to go commercial, you could always get a lower resistance turning potentiometer to put in there, and smaller ones that would be more fit, or would be more appropriate. So yeah, so that's where we are right now. The accelerometer, very cool. Does have its uses, just not the one I want exactly, except for in a limited capacity. I might end up using it, but I am going to try and take a stab at using a gyro independently, and then trying to use a gyro along with the accelerometer. And then as far as for finger position, whether it's open or closed, right? Or like I said earlier on, I'm going to use the buttons, which will close, open and close on the shapes in there. Or I will go ahead and use these potentiometers to measure the angle of my knuckles right here and here. So here and here, and that will give me a which is at the actual knuckle and then the first digit or the first bending joint in your finger, because your second bending joint, your second joint in your finger really doesn't do all that much. And if you calculate that the first joint after the knuckle has bent by a certain much, you could just by ratio bend that second joint and get a pretty close approximation. Because if you look at the way your hand works, you very rarely bend that second joint without bending the first joint. So I'm not too worried about measuring that joint. So yeah, so do that, and what I'll probably try and work on next month and a half is to get 6 potentiometers set that way. 2 for the thumb, 2 to measure the index finger, and then I'll probably just calculate these 3 other fingers, your pinky, ring finger, middle finger, all together, because it's not too often, except for when typing and stuff like that, that we actually use those fingers independently. By the time you start flexing those into a grip, you're actually trying to hold something of sturdy, of weight, or hold it firmly, because you couldn't hold it from your index finger and your thumb. So that's kind of where we're going. You have a device that measures the orientation of your palm mounted to the back of your hand, since those are parallel planes. You'll have something that measures the articulation of your index finger, probably the 3 other fingers together, and your thumb. And then you'll have 2 haptic feedback vibration motors, and then you'll have this big like stack of Arduino shields and whatnot, and all that done Bluetooth, so that we're not being restricted by more wires. So that's kind of where I'm going, and I just want to share the lessons learned, time put in on trying to get this accelerometer to work the way I want it to, but it's just by its nature is not going to do what I want. So yeah, so hopefully maybe that supports or helps someone else. Or there you go. If you have any questions, just post below. How we going?